Good morning everybody, Physics IGCSE second term, and we are now in week 1 and this is the third session of week 1 and we're concentrating on section 4.3 in the book, and once we're finished with this we'll be done with chapter 4 and you can then attempt all the end of chapter questions. Alright, equilibrium. This is just a recap from the last section, and I need to emphasize this. If we have an object here, or a beam as I like to call it, this beam has a pivot, okay, and we have forces here. Let's have a force. There's a force here of 500 Newton. There's a force here of 400 Newton, and there's a force here of 300 Newton. Okay. What conditions do we need for this to be in equilibrium? There's two conditions that we need for equilibrium. The first condition is there must be no net moment. Okay? No net clockwise moment and no net anti-clockwise moment. In other words, this force multiplied by this distance must be the same as this force multiplied by this distance plus this force multiplied by this distance. Then you will have no clockwise moment. Secondly, you need to take into account the actual weight of this beam. If this beam has a weight of 200 newtons, then you need to add all these forces. These forces will all be acting through this center here, and there's a contact force acting upwards, and that contact force has to be the same as all of these forces together. So this is 3, 4, 7, 9 and 5 is 14. So this would be 1,400 Newton that way. Now the forces, there's no net force in this direction, so this will not move that way and this will not move that way. So that's the two conditions that are necessary for equilibrium, and if you want to do calculations, you need the system to be in equilibrium, because there's going to be an equation, and in equilibrium means that there's an equation, the left side is equal to the right hand side. Okay. Right, and that is the concept of equilibrium. The next concept that I want to deal with is the center of mass. Center of mass. So if you have a glass of water standing here, something like that, okay, with a base like that, the weight of the glass is pushing down equally all over onto the glass, onto the base, because the glass is standing upright. So we can actually view all these forces from the glass pushing down as one force going through the middle of the glass. And that middle of the glass, this dotted line, will pass through the center of mass of the glass, which will be somewhere over here. Okay? So as long as this glass, the center of mass and this line are lined up, this glass will not fall over. Okay? If the glass tilts slightly, like this, there it is now, there's the glass again. Now, there's a pivot here. the glass is tilted. This is now the line that we're looking at. This line, the center of mass has moved to one side, and we have forces going down this way to the left of this center of mass and to the right of this center of mass. But in this case, you'll see that the forces on the left are actually more. There's more of the glass on the left than on the right. This is a very obvious concept. We know this because we've all bumped over a glass of wine before. So you can see there's less of this glass here than over here. Okay? So if your elbow did push on this glass and you took your elbow away, this glass would go back that way. Why? Because it's you can view this as a pivot with a beam like that, okay? And you'll find that the forces on this side is more than the forces on this side. That means that there's an anti-clockwise moment that tends to turn the glass back upright again. But now if the glass had to tilt further, let's have it tilting here on this pivot, then you'll find that only you actually need to do the glass first. There's more forces here, stronger force here than there, and then you will have a if we draw perhaps like this is our beam now like that. Then we will have a clockwise line, and the glass will fall out. Okay. So, you should now be able to understand everything in the chapter. If you have any problems, please contact me. Thank you.